My name's Ian McLaughlin. I'm a principal application engineer at Discover Financial Services. Not many people have heard of Discover. We've got the booth downstairs, and most people have never heard of them. They're actually a huge company. They are very well known, household name in the US, employing about 20,000 people. They're a bank. They own the network. They own Discover Card, Diners Club. So they're a very well-established company. And we just, there's a small UK office, about 500 people, and I work there. It's just a bit of background. Some people think we're a small startup, but it's quite a big, substantial company. Okay, so I'm going to talk about extreme programming. I'm going to talk about why do we need XP. I'm going to talk a little bit about continuous refinement, pair programming, BDD, behavior-driven development, test-driven development, a little bit about agile with XP and some of the challenges that we've faced. So why do we need XP? XP is a way of delivering quality software. The reason we need quality software is because if you don't produce quality software, it can have severe consequences. I just put up a few examples that came to mind in the last couple of decades. You had the recent TSB one, data migration, botched. They were fined a whole year's profits, 50 million. EDS, an old child support system in the early noughties that went totally wrong. It resulted in £150 million loss. But my favourite example is the post office Horizon system, which led to people committing suicide. So it's a serious issue. If your software doesn't do the job it's supposed to do, it can end with serious consequences. So the goal of extreme programming is to avoid the risk of these software disasters. So why do we need XP? It ensures the quality of your product, and it steers you away from these catastrophes. So I like to think of it of coding as it should be like an Uber driver or a forklift truck operator, where you have a schedule of operations that you need to carry out. You don't have big peaks and troughs in your work. You just have a prioritized list of jobs. You can work calmly through your work. And this is what software development should look like, and this is where extreme programming steers you. So just a few other things that I'll talk about before I get into the main stuff. Pair programming and test-driven development are the key subjects today, but just a few other things I thought I'd bring in at the beginning. We do a lot of continuous refinement in our team. There's a tendency for some teams to do big refinements. So you have like a 3-hour, 4-hour session every 2 weeks, and you try and refine all your stories. And it gets really boring, and nobody really gets, after an hour or so, people's concentration goes. We try and do this every day. So we do a little bit of a story every day. People go away, they're allocated to look at some of the detail at a problem, and then they'll bring it back to the team. We'll do half an hour, 20 minutes, and maybe we'll get one story pointed. And it's a really useful way of keeping the wheels turning, because obviously you always need stories to work on. So that's continuous refinement. This is one of my key topics today, though, pair programming. So this is the Wikipedia definition. I won't read it out, but the idea is you have two people working together. One's sort of the primary, one's the secondary, and the primary is the main kind of driver, if you like, and the secondary is the navigator. So let's go into a bit of detail with that. So right, this is a key concept. If you want to go fast, you go alone. If you want to go further, if you want to go far, you go together. So you've always got this idea that you can, if you're working on your own, you can get a lot done very quickly, but unfortunately you've left the whole team behind you. And that's not sustainable. It's good for a burst of activity, but really, from a company's perspective, it's not ideal. You want the team, you want to carry the team with you. It's an old African proverb, though. So what are the benefits of pairing? Pairing can build a team. It makes coding much more sociable rather than being a solitary experience. It creates mutual understanding in the code base. It breaks down barriers, so you get to know people in your team rather than just working on your own. It also breaks through cultural differences. So we have very diverse teams at Discover. We have people working in Romania, we have Poland, India, the US, people from Mexico. So you have a big mix of people, and sometimes when you're working on your own, you don't really build up those connections. When you're working alongside someone for a whole day, you really do get to know that person, and you develop a social relationship. I'm sure you've all come across personality clashes in teams. If you're working with someone, if you're pairing with someone for several days, literally hour by hour working with them, it's less likely for you to have a personality clash. You might not love the person, but you'll grow to empathize with them. You'll understand what makes them tick, where they're coming from, maybe what their hobbies are, and it just helps. It sort of helps turn the wheels of software development. It gives you a different perspective. Everyone has a different idea, a slightly different idea about how a job should be done, and these different perspectives can be really useful. It also reduces stress. So when you go to your stand-ups, you've got two of you. If you've been blocked on an issue all day, you can back each other up. You don't have this feeling that, oh my God, I haven't got any work done. What am I going to say to my boss? There's two of you. They say, look, we've been blocked. We've come across this really difficult problem, and we're both stuck. So it just inherently becomes less stressful, makes the stand-ups more relaxed. Important concept with pairing, though, is you must rotate pairs. You can't have these golden pairs staying together week in, week out, which can happen actually. You need to stop it from happening as a tech lead or a tech anchor. You change the pairs ideally every few days so that you get this mix of knowledge. You get different people pairing with different people, and the knowledge becomes shared around the team. It's very powerful. You should also stick to an 8-hour day. You don't have these ridiculous 14, 18-hour days where one person's slogging away at a problem. 8 hours is enough. Pair programming is quite hard work. It's not easy, but after 8 hours, you've done enough. And going back to the pair rotation, you move away from the concept of a hero programmer that's carrying the whole team, which is not good for the company, because if that guy goes or that woman goes, you've lost your product. Pair programming is really good for remote working. One of the guys who I initially worked with when I joined Discover, who was a big advocate for pair programming, he suggested it doesn't work for remote. But then we had the pandemic. Everyone had to remotely work, and the pairing actually worked really well. It meant you were never isolated. You're always in touch with someone, and because we were rotating pairs, you had this continuous communication throughout the team, through the day, and then the stand-up at the end of the day. It worked really well. So it's great for team building. You share the experience, fills in the knowledge gaps. You get to see different approaches, and it allows you to be creative. Sometimes if you're on your own, you might feel a little bit constricted as to what kind of options, what solutions you might suggest. If you've got someone else to bounce the ideas off, then you'll and they agree with your creative approach, then you feel much more comfortable going forward. You don't feel like you're going out on a limb. So you bounce the ideas around, allows you to innovate, and you get this synergy of two different perspectives coming together, and the sum of the parts is greater than the individuals. It also helps reduce risk. So if you come up with a crazy solution and the guy you're working with tells you it's a crazy solution, then that kills it in the board. So you don't. It inherently limits these crazy solutions and non-standard approaches. So you have a collective ownership of the code base, which happens in our team now. We don't really have a story that this guy did. It's like, oh, well, this person worked on it, that person worked on it. And it becomes a much more sort of shared ownership of the work. Gives you a high confidence in the solution because we've recently just delivered a piece of work where everyone had worked on it for at least a day or two, so everyone was pretty confident that it was going to work. no single point of failure, so you don't have one person who we're relying on to do all the fixes. It's great for handovers, like if you need to go on holiday or you're sick, then you've always got your other pair, your other half in the pair to carry the basically carry the story forward. So yeah, it covers holiday, maternity leave, sickness. Very kind of low impact when you roll off a story and you need to go away and someone else can just fill in your place. And obviously if someone wins the lottery or hit by the proverbial bus. Pairing increases efficiency. It can unlock problems. So if you might be just staring at a screen for hours and hours, if you've got someone else working with you, then they might come up with an idea and it might unlock the problem. It helps you maintain focus. If you're working on your own, often you can just drift off and maybe spend half an hour making a cup of coffee. But if you're working in a pair, you feel a little bit socially obliged to kind of, put your hours in and just do the work. Stops you going down wormholes. So I've done this a lot. Sometimes it can be quite productive. You come across a little problem and you get a little bit obsessed by it and you go off and you explore it and you might do a training module. You're still supposed to be delivering something that week, and it's good if you've got a partner, then they can come in and say, look, we don't really want to go down. Let's just focus on getting this story delivered this week. Means you always come up with simple designs. If you're pairing, you don't come up with these sort of crazy options. And also because you've got two minds working together, you get to evaluate more options. It smooths out the low points. So people have a natural rhythm through the day. When someone might be having a bit of a lull, then your partner can kind of step in and just pick you up, and what you find is you maintain a sort of consistent level of output through the day because you've got the two people working together. It's great for new starters. So we love getting new people in the team. If there's ever anyone who's spare and needs to come into our team, then it's just like, bring them in, just stick them in a pair and off they go. There's no kind of learning curve really, because they're straight away into the coding. They can come up with good ideas. They might not know the whole system, but anyone who's pairing can normally come up with some good ideas right from day one. Quite useful to use in an interview. I've done this quite often myself, where you'll pair with someone and you can work out how someone's mind ticks. So the studies have shown that working as a pair is probably about 60%. You get about 60% of the work done in the same time as a solo programmer, but at the same time, the actual quality of the output is much, much higher, and the chance of future work needing to be redone is diminished. So that goes into improving the quality. You come up with simple solutions, makes you adhere to coding standards because you've got two people looking at it. If you start doing anything a little bit off the wall, you'll get your partner saying, no, that's not quite how we should be doing it. Also, it forces you to do regular commits. So if you're pairing with someone, the idea is you'll switch between driver and navigator throughout the day, and it forces you to kind of commit your code, and then someone else, your partner, can pull that code and start working on it. It's effectively a continuous code review, having a navigator sitting alongside you. Continuous code review, continuous QA. And this all feeds into the concept of continuous delivery, where you're dropping small pieces of functionality into production with a measurable increase in quality. So this was just a little thing we did a few months ago. We tried speed pairing. We always had this idea for what's the best cadence or the frequency for changing pairs. Some teams like to do it over a whole sprint, so maybe like 2 or 3 weeks, which I personally think is too long, but you kind of got to go with the team. I found you can't force people to rotate too often, otherwise they'll resist it. But we just, for a bit of fun, we tried this 1 hour pair change exercise, which it sounds crazy, but it was actually really enjoyable. One of the takeaways from it, though, was the story owner, the driver, who was continually having to take on new passengers, if you like, because if you take the Uber metaphor, it was very tiring and time consuming for the driver, because he had to keep re-explaining and re-explaining. But that in itself is not a bad thing. To have to keep explaining a problem means that you have to know and understand the problem yourself, and sometimes the act of explaining can reveal stuff to yourself that you didn't even appreciate was there. I just quickly show you that this was our Miro board. This was our chart. There's me at the bottom starting on support, and we just rotated round. So here's the driver, there's the navigator, and that was our whiteboard in the office. This is all real. I didn't make this up. And now here's a little quiz. Can you guess who's not pairing? There's one person in the photo. I'll tell you, it's the person in the top right there, Leslie. She's our architect. She wasn't pairing at the time, so everyone else is happy. Leslie looks like she's under a bit of a strain there. Here's some of the comments. I won't go through them all, but generally people enjoyed it. But as I said before, the main thing that came out, it was the drivers felt a little bit kind of a bit under stress. So it's not something I'd recommend you do all the time, but it's great to get people back in the office and have a bit of fun, and it does spread the knowledge around quite effectively. So problems with pairing. It's not without problems, it has to be said. It's difficult and tiring. There's no getting around it. It really does. It saps your energy. So the best way to approach it is to switch roles. So you have one driver who writes the test, and then you switch. So the navigator becomes the driver, and they try and write some code to pass the test. That's the standard format. You have to beware of this no rotation. People like to stay in the same pair, and it really is a good idea to make people change. Otherwise, you lose a lot of the benefits of pairing. Take people out of the comfort zone. Yeah, 2 days. We actually do a 1 week rotation now, but we have done 2 or 3 days, which I think works really well. Yeah, people think it's slow, but as I said, it produces quality software. It's not so good for configuration stuff that's not very creative. Yeah, daily rotation. So there's different permutations. You could have 2 experts working together, which obviously works well. An expert with a novice works well as well, because you've got the knowledge transference. Interesting one is you get a novice with a novice. It gives them both. So you could have 2 graduates maybe working together. It gives them. They don't feel isolated. They can bounce the ideas off each other, and they can just call in help if they're stuck, and they don't feel like they're losers or anything. They understand that they're on a learning curve. You must take frequent breaks, and I'd recommend trying it for a few sprints. As I've said, it's really good for remote working. I'm just going to skip through some of this because I'm just looking at my time. It doesn't have to be high tech. You can literally just do it sharing screens. Lots of software out there. I think IntelliJ's got an option to pair code, but you can literally just share a screen, have one person typing and the other person just looking over the shoulder and commenting about what's happening. So this is the idea. So you have a driver in the driving seat, navigator just watches what the driver's doing, and then you switch roles. I'll just skip through that. So summary, it's good for team building, enhances learning, reduces risk, increases efficiency and quality. Okay, right, behavior-driven development. When you're writing a story, so this kind of feeds into TDD, but obviously the top of the tree is BDD, behavior-driven development. Key thing, start with the demo. So if you can't write a demo for a story, then you need to rethink it, because if it's not demoable, you're not really producing anything of value. You can use a simple story template, as I want so that. For your acceptance criteria, obviously you can use the given, when, then. You don't necessarily need to have acceptance criteria and scenarios with your given, when, then criteria, but some people like to have both. There's a choice between, for your code reviews, do you do mob reviews or individual reviews? GitHub can be configured so you have 2 people who can accept a change into your code base. I actually quite like mob code reviews, where everyone just dives in and comments. Okay, test-driven development. So test-driven development stops you chasing coverage stats. So I know I've worked on a team before where the typical thing, they'll write the code and then they'll try and write a test to test the code that they've just written. And sometimes the test doesn't even, you could take that production code out and the test would still pass, but you've done your coverage, you've got your coverage stats, which is not, it's not really how your testing should work. So the key thing is you start with a failing test. You don't change any production code without first writing a failing test. That's a key concept. It can be difficult when this doesn't just apply to Java. It can apply to any language at all. So I've actually applied TDD to Delboomi, which is a cloud-based ETL tool. You basically just use the ETL tool to test itself. So you test that the flow that you've created is actually doing what it should do. I've used it for ETL for Informatica as well. Just basic shell scripts to check that when you run the flow, the right output comes out the other end. I don't know how many people are familiar with the test pyramid. So you've got your three main levels of testing. At the top, you have your system tests, which should be few in number, but test the whole thing end to end. Then you've got your system tests, which are in the middle, which will test groups of components, but you don't have to run the system. And then your unit tests at the bottom, they just test your individual bits of functionality. Unit tests the quickest. Now, for pairing, your driver will write the test, then you swap roles, and the navigator tries to make the test to pass. It forces you to frame the problem correctly. So these are the benefits of TDD. So it makes sure that the code you write is easy to test. If it's easy to test, it will, by definition, be more reliable. Now, one of the key things is you don't optimize. This has been a long-running argument in various teams I've worked in. To make the test pass, you can make it as dirty and horrible as you want. Just make the test pass. You can put duplication in, hard-coded values. Just make the test pass. Once you've got your test passing, or all your tests passing, then you can start to refactor. And because you've got your tests there to tell you whether you've broken anything, you know that your refactoring has succeeded. You've not broken anything with the refactoring. Right, so these are some of the laws. This is just straight off the internet. You don't write any production code unless you've got a failing unit test. You don't write too much of a unit test. Just write enough of a unit test so it fails, and you're not allowed to write any more production code than is sufficient to pass one failing unit test. And you can simplify that. You can just say, write only enough of a unit test to fail, write only enough production code to make the failing unit test pass. So it's small increments. You write a small failing test and then write some code to make it pass. So once the story is completed, satisfying multiple test cases, then you can refactor, as I've said. Then you can go do all the good stuff, get rid of all your hard coding, your duplication, make it all lovely. Okay, I'm just going to do a quick, show you a quick recording of a top to bottom TDD. So this is going from BDD right down to unit testing. I can play this. He says, how do I play? Okay, so there's the BDD. So given the application is running, when I hit the greeting endpoint, then I see the hello world message. This is the simplest example I could think of that we could do it from top to bottom. So this is an API. I'm going to write an API that basically gives you a hello world message. So it's a Spring Boot application. And what we do is there's a tiny bit of production code. I've cheated a little bit just to save time. We've got the My application there, just that. So what we're going to do is we're going to write a My application test, which is basically a Cucumber runner with the associated feature file. And the feature file, lo and behold, takes a few seconds for this to come up, but this is just going to be the BDD. So this is your given, when, then. So given, I've got a greetings application. When I hit the endpoint, the greeting endpoint, then I'll see a hello world message. Just give it time to catch up. And then, so the idea is what we're going to do, is what I'm going to show you is you start at this very top level, this Cucumber feature file, and then you drill down and you write another failing test. So this is your Cucumber system test, if you like. Then we're going to do an integration test underneath that, and then a unit test at the bottom. We're just going to do the sort of 3 levels of the pyramid. So here we go. There's our given, when, then. So given the application is running, when I hit the greetings endpoint, I get hello, hola mundo message. IntelliJ is really nice. It'll just create all the step defs for you. Just take a glass of water. So we'll see IntelliJ pop up with the step defs in its own time. So once we get these the step definitions are the bits of code. I don't know if you all know about Cucumber. The step definitions correspond to each of those lines. There we go. It's just a bit of Java code that gets run. The first bit, we just put a placeholder in, just a to-do to check the health. We can come back to that. I just wanted to keep it as simple as possible. What we're really going to do, we're really interested in this bit here. I see the message. So we hit the greetings endpoint. We put a bit of code in there to hit the greetings endpoint, which we haven't written. We haven't written anything yet at all. All we're doing is writing a Cucumber test. And then once that's done, come on, hurry up. So there we go. We've got a REST template. I've just got it to hit the local host running locally, and there's the greetings endpoint just there. And we want to see the message coming back from the greetings endpoint, so we just got to check that coming back. I tried to do this as quickly as I could. It runs in about 5 minutes. So there we got our assertion. So we're going to assert that we get the correct message back from hitting that endpoint. And remember, no production codes have been written yet. So after this, we're going to go into the controller test. So we've got the application test, which needs the application to be running because it needs to hit that endpoint. Then we're going to go into the controller test, which will use mock MVC to sort of simulate the endpoint rather than actually running the application. So that the next step would be this integration test would be ran typically as part of the build without having to have the application running. Hurry up. So, okay, what I'm doing here is I'm showing the failing test. So we're running our Cucumber, and we'll see that we get a 404 not found because obviously the greetings endpoint isn't there. Got enough time left. So now we're going to create the Cucumber runner. And this is how we work. I've gone through this cycle many times at Discover, where you start right at the top of the problem space and you just drill all the way down through your code. I mean, typically you'd already have your runner here, but I just wanted to show you it from top to bottom, so you could recreate this for yourself just straight out of the box. Right, there we go. 404. So it can't find the greetings endpoint. So that's our top level system test written. It gets quicker. Sorry. So now we have the controller test, and this is going to use mock MVC to create a dummy. Or to simulate the application is running. So this can be run independently of the application. So I've just pasted in a lot of this is just boilerplate stuff. But the important bit is you've got the perform the greeting there, and then you've got the result being stored in the greeting. Then we've got the assertion that the greeting is hola mundo. So this can all run without the application running. Okay. And now from this, now we're going to go in and we're going to write a unit test for the underlying service of the controller. In its own time. There we go. So we've run that, and we've got the so the expected result of Mundo is nothing coming back at all. So now we can create a unit test. So we've got the application test, we've got the integration test, and now this is the unit test. Remember, we still haven't written any production code yet. This is all just tests. So this is the service test now. So underneath the controller, we're going to have a service that actually supplies the greeting message back to the controller. So all we have here is a this my service doesn't exist yet. We've just written a test. We know we're going to want my service, and we want my service to have a method called fetch greeting. Now IntelliJ very helpfully, just doing all the boilerplate stuff there, but IntelliJ very helpfully is going to tell us you haven't got a my service. So you can just click use IntelliJ and it'll just create your class for you, which is quite nice when it's finished doing all the annotations. Right, so my service, create a class my service, thank you very much. Yes, created in that package. So we've got an empty class. Now if we go back to the code, we can see it complaining there. It's saying it couldn't auto-wire it. Thank you for that. So we need to go back and we need to annotate it as a service. So we can now instantiate that. We can auto-wire that in our test. So now we're actually starting to write production code, but just prompted by IntelliJ. Again, it wants the method, fetch greeting. It says you haven't got a method. Do you want a method creating? Yep, so we just create an empty method. So we've got an empty class with an empty method. And we're just going to leave it like that. I'm not going to return anything from this method. We're just going to run the test and see what happens. So we're expecting hello world. And I'm just going to put return null for now. So when we run the test now, so we can run so remember the unit test can be run really quickly. So these typically you have hundreds of these unit tests, I'm sure you know. We run this test, I think we know what's going to happen, it's going to fail, and it fails because there's a null return. So now this is the key point where, right, this is where we actually need to think about what do we want this service class to do, and we want it to return hello world. So that is where we've actually started writing production code. So we've written all those tests, we've just put templates in for all the classes, but this is the point where we actually need to say, right, this service needs to return the string hello world. And now, this is the really nice bit. When you go back up the tree, so that's all quite time consuming, I know, but as you go back up the tree now, everything just clicks into place. So we now run our controller test, and our controller test is going to do what? It's going to complain because, I'll let it run. So it's not getting anything back because we haven't implemented the controller. So we need to put the controller in that connects the controller test to the service. So we create my controller. So there we go. It does something, it's not very complicated. It's just a greeting endpoint. And all it's doing is it's invoking the fetch greeting method in my service and returning that greeting. So you could collapse lines 13 and 14, obviously, but the whole thing is just write it so it's quick and dirty at the moment, make it work, then you can refactor. So if we run this now, it still fails. Why does it fail? Hola Mundo, hello world. So if you remember in the original spec, we really wanted it to come back with hello world, not Hola Mundo. So we've actually implemented the test being incorrectly implemented in the real world. You go back to the spec, you'd say, well, what does the spec say? It's hello world. And then the final step is really, really quick. So we've got the, so that's passing, and then we go back up to the application test. We run that. We need to run the application, obviously. So we need to run the application now, run the application test, and we will see. So the application is running. And if we start my application test, I think we'll find that it fails because we misimplemented the spec. So if you look, it's looking for Hola Mundo. The actual is hello world. Go back to the spec. What does the BDD specification say? It said hello world. So we changed that. We changed that living spec to say hello world. And then when we run that, that should pass. We'll just see it pass. There we go. 4 test pass. So that's just a quick. So that was less than 10 minutes from top to bottom. And if you see, more than 3/4 of the time there was spent writing the test. It's only a small amount of time you actually have writing the code. So that was TDD. So just a few more thoughts about XP and and Agile. This is the way we work. We have once a day stand up. We always have the cameras on. We have a relaxed icebreaker. Usually we spend 15 minutes. Each team member takes turns to ask a silly question. It could be just something like, where did you go on holiday? Do you like coffee? Do you like tea? It's amazing the conversations that come out of that and the connections that you make. So you make these stand-ups fun. With remote working, this worked really well. A lot of people want to skip it. They think it's nonsense, but I passionately believe that I think laughter is an important part of your day, I think. And yeah, everyone needs to work together. If everyone's working together and you're pairing and you're implementing TDD, then you have a very sort of powerful, you've got a powerful combination of things there. Yeah, don't underestimate the soft skills. So repeated, this is just general kind of psychotherapy. My wife's a psychotherapist. Positive reinforcement, always emphasize the good. If someone makes a mistake, I don't think people should dwell on it. Maybe once in a while you can offer advice, but generally everything should be positive. Yeah, you can apply this to your. It can work for your co-workers, your managers, or people underneath you. Okay, so Agile XP. Instead of delivering everything you could possibly want on some date far in the future, Agile XP delivers the software you need as you need it. Key concept. Team velocity is not a measure of productivity. Nearly everywhere I've worked falls foul of this. Managers will use team velocity to judge how good a team is or how productive it is. It's nothing to do with that. And if anyone suggests doing that, they should not do it. Team velocity should be used to ensure your predictability of delivery. So it ensures you know what you can deliver in what time frame. That's it. It's nothing to do with productivity. Use spike stories. When you're dealing with new technology or legacy code, so a spike story is kind of a research story. We usually just put 3 points on it and just let a pair go away for a time-boxed amount of time and do a bit of research. Very powerful. Just stressing again the idea of pairing and TDD means you have this kind of embedded continuous QA, which is perfect. It means you don't really need to have a separate QA function. Just a few final thoughts. Here's just a random list of things that I didn't include in the main presentation. So the cucumber tests self-document the system. Mob code reviews, I think, are a great idea rather than just 1 or 2 people looking at the code. Feature switches are a really powerful thing where you deliver stuff to production, but you turn it off. So there's no impact on your production system. You turn it on when everyone's ready. And that can be really useful. It stops everyone tripping over each other with multiple branches on branches and long-running branches. It means you can have short-lived branches. You put the functionality back onto the trunk, but you turn it off, turn it on when you want it. Dark live is a very hot topic for us at the moment. The idea of delivering something to production that's turned off, like a whole new API. So it's not visible. It's in production, but it's not live. Big distinction. You do get resistance. I think I'll talk about it in another slide. You do get resistance from the SRE team. They're a bit uncomfortable about doing pilot releases to production. But we should push for get stuff into production, even if it's not turned on, so we can work out where all the snag points are. Drip feed stories into production, so no big releases, no big bangs, small releases, continuous delivery refinement. So this thing, multiple teams working on the same component plus slow time to prod equals disaster. This is, I've seen this happen. So if you've got lots of long-running branches and nothing's going to production, you get stacks and stacks of functionality that need to go to production all in one go. You get these ridiculous pull requests of massive amounts of code changes that no one can really understand. You need to avoid that. Small changes frequently. That's the key. So this time to prod. Time to prod is a really tricky one. You need to keep pushing stuff to production, not delaying it. Fail fast, fail early. So if there is something wrong with your pilot release that's not going to be turned on, it's not going to be released to anyone in the outside world, you want to see it, if it is going to fail, you want to see it fail early rather than later. Some of the challenges with XP, is it production ready? So you might have a pilot release that you're ready to go to production with, but the SRE team are saying, no, you can't go to production because it hasn't got this, hasn't got that. So, well, we don't care. We just want to see it in production so we can flush out any problems. We're not going to give it to anyone. We want to test the pipeline, which feeds into incremental delivery and regulation. So basically that's conforming to coding standards. Or you might, so this is one thing we had. We had a timeout facility on some of the endpoints that we hadn't implemented. And there was an argument that we shouldn't put anything into production that doesn't have this kind of timeout on the endpoint that'll stop, and we said, well, we can implement that as a follow-on. But it's this whole idea of having all the bells and whistles. That's my next point. All my bells and whistles on the actual, the release. It shouldn't be necessary to have everything there, the whole thing. You should be able to do pilot releases. That's basically all I'm trying to say. Broken pipelines, just the bane of our lives. So not much we can do about that. Okay, just to sum up then. XP may initially appear slow and painful, which it is. It does feel slow, but it's fast. You need your buy-in from your managers. You can't do it if senior management don't do it. At Discover, they're very keen on us to use all these XP techniques. They're very understanding of, maybe it'll take a little bit longer, but the quality is better. It gives you a predictable outcome, which all businesses want, obviously. Reliable, maintainable software, what's not to like, and it saves the company money. And this is my favorite quote. My last presentation, someone came back to me with this one. So apparently it's from the US Navy SEALs. Slow is smooth, smooth is fast. So, 7 minutes for questions. If anyone's got any, or if not, you can have 7 minutes of your life back. Yeah, go on.
Cool. Yeah, I saw the TDD demo was quite interesting. I noticed you started with like a system level test.
Yep.
At the top. We do a similar thing where we try and write the acceptance tests first and watch them fail. And we've noticed that
they should all fail.
Yes, of course. But I think the problem that we have is we want to continuously integrate our changes frequently, and it might take longer than a day, for example, to make that system level test pass. We want to be integrating like at least once a day and pushing our code into trunk as quickly as possible.
Yeah.
So how do you deal with that? How do you not break the pipeline when you've written a test that takes a long time to complete the acceptance criteria.
So timing is tricky, actually. If you've got tests that fail because of the time, then I haven't got any magic bullet for for that one. We have experienced that as well, where you've got tests that are kind of time dependent. I guess the answer is it's a flaky test, and maybe you need to go back to the test and work out why it's so reliant on time, and maybe think about a different way of implementing it.
Yeah, I mean more in sort of the time it takes to develop the code to pass the test. So if it takes you 2 days to implement the production code to pass your system level test.
Well, I mean, it has to pass the test. If it doesn't pass the test, then it's not ready, is it? You're not going to. You would never go to your product owner and say, "Oh, we've implemented something. It doesn't work, but we want to push it to prod." It's like, no, just get it right. You need to get it right.
Yeah. Well, you might with your feature flags and dark releases, right?
You could turn some of the stuff off, yeah, but it should work. It shouldn't be buggy.
Cool. Thanks.
Sorry. Anyone else?
Hi. I just wanted to ask about how do you prepare the data to run the test against?
So all tests should be, actually I didn't talk about this, all tests should be totally self-reliant. They should spin up their own data and tear down their own data. That's a key concept. I've forgotten to put that in. Yeah, so self-sufficient. Tests should be self-sufficient. That's the key concept.
Before every test.
So every test you write should have its own setup, so where it writes the data that it needs to into the database or wherever. It gets executed, the test gets executed, and then the data gets removed. You don't run destructive tests outside of your dev environment. You have light touch tests smoke tests in your higher environments. In your lower environments, you should be free to inject data and tear it down.
Can you define that in Cucumber?
Yeah. Your Cucumber step can do anything it likes. I mean, we have all sorts of setup and tear down in our Cucumber. I mean, I picked a very simple example just for the sake of brevity, but your Cucumber test could. We've got Cucumber tests that write a ton of data to the database, and then it gets removed at the end.
How do you recommend selling or starting with pair programming for a team that's new to it or skeptical of it?
Try it. I think that that's what I said on one of the slides. Just try it for a couple of sprints, because I've actually done this. I've managed a team that didn't really want to do it, and I said, "Well, just try it," and they grew into it. And I think there's no point pretending that it's easy, because it's not. It's actually, I mean, I remember the first time I did pair programming, I absolutely hated it. I did it for 3 days and then I never went back to it for years. But then when you go into a team that's a bit more mature, where you can just sit back, I think people have this idea that you've got to be work, you've got to be constantly typing all the time. When you move away from that, and you both of you can just sit back and say, we're kind of stuck. Should we go and have a coffee? Go and have a coffee for half an hour, have a chat. You need to kind of instill that kind of mentality into people, where it's okay just to take a break and just get away from the screen and chat about it. And maybe if you're stuck, bring in someone else and just have it's kind of like software development in a sort of discussion forum, rather than it's trying to get away from the lone programmer, working 20 hours a day, day in, day out. That's where we're trying to get away from, because that's dangerous. No company needs that. Got 1 minute. Yeah, go. One here. Oh, sorry, go on.
Hey, thank you for your presentation. Another fintech guy here. So fintech without tests is not possible.
Yeah.
So quick question. Do you see any scenarios where you don't do bottom up, but you sometimes can do up to bottom, especially when you have, in scenarios where you don't have code at all, so you write a system or a component from scratch?
So I know sometimes we've tried to create a failing test, and we found out that there isn't a failing test. So you write the test and it actually passes. And there's this notional idea that we needed to write some code. We actually don't need to write any code. The code's already there. It's all baked in. Is that what you're getting at? Well, I guess, yeah, if you can write a test that proves that the functionality of whatever system it is, you might have something off the shelf you're not sure whether you need to add some kind of functionality, you write a test and you can prove that it's working. And
When your architecture is not defined yet, everything is very fluid, so you know you can change many things. So what I'm saying is, does it make sense to write from up to bottom sometimes in some cases?
personally, I think you always need to start with the gherkin, the BDD, given when then at the top, because that defines the whole behavior. I think I'm out of time. 1 minute. Anyway, thanks very much, guys and girls, I should say.